Your house was built to protect you, and most of the time, it does. But for about 3 hours a day, in moments you probably haven't noticed, it switches sides. Not because something is broken, not because you did something wrong, because there are 7 specific points in your envelope, 7 places where the physics inverts, where the shelter stops sheltering and starts working against the person inside it. 7 moments of betrayal. 2 of them are responsible for most of the damage. We're going to name all 7, locate them, and then talk about which 2 you fix first. Let's start with something you've probably felt but never explained. You wake up on a cold morning, the house has been closed all night, the thermostat did its job, and yet the air near the ceiling feels stale, and the floor feels colder than it should. That's not your imagination. That's number 1. The chimney stack effect at 7 in the morning. Here's what happens. Before sunrise, the interior air has been stratifying for hours. Warm air rises. Cold air settles. That's physics. And it's fine. The problem is that your house is not sealed. It never is. There are gaps. Around the chimney chase. Around recessed lights. Where the ceiling meets the exterior wall. And at around 6 to 7 a.m., when the temperature differential between inside and outside is at its steepest, the pressure stack inside your house reaches a peak. Warm interior air finds those gaps at the top. It leaks out. Cold exterior air gets pulled in from below, through the floor, through the rim joist, through any penetration near the foundation. The house is breathing, but it's breathing wrong. It's exhaling your heat and inhaling cold ground air. This is not a dramatic event. It doesn't trip anything. You can't hear it, but you can feel it. That cold ankle sensation in winter mornings that no amount of thermostat adjustment fully resolves. The fix is not more heat. The fix is reducing the pathways at the top and at the rim. But we'll come back to that. Number 1 accounts for a real but modest portion of your envelope loss. Annoying, but not the main event. Number two is the single heaviest item on this list. It happens at 4 in the afternoon, in summer. It's the west wall re-radiating. Here's what you need to understand. Your west wall doesn't behave like your other walls. In the morning, the sun is on the east. By noon, it moves. By 2 p.m., the west-facing surface begins receiving direct radiation. By 3, 4, 5 p.m., it's receiving low-angle afternoon sun, the harshest geometry of the day. And here is the part most people miss. The wall doesn't just heat up on the outside, it stores. A standard wood frame wall with vinyl or fiber cement cladding reaches exterior surface temperatures of 140 degrees Fahrenheit to 160 degrees Fahrenheit. That's 60 to 70 Celsius. On a normal summer afternoon in the continental U.S., that surface has been absorbing energy for 3 hours before it peaks. And then, even after the sun drops, it keeps radiating. Into the room, through the drywall, against the air you're trying to cool. At 9 p.m., you're still receiving heat from an event that started at 2 in the afternoon. No window open at 10 p.m. will flush that load. The wall has already won. Your AC isn't fighting the outdoor temperature at that hour. It's fighting stored energy from a surface that was effectively a radiator for 6 hours. This is why the master bedroom on the west side is always hotter than the rest of the house after dark. Not because of poor ventilation, because of stored thermal mass in the wrong place. Number 2 is a big one. We'll talk about what you do about it in a moment. But hold it. Because number 5 shares the same weight class. Number 3 is quieter. It happens at night, on the coldest nights in the ceiling. It's called ceiling bypass. Your ceiling insulation, whether it's bats or blown in, is doing its job inside the insulated cavity. But insulation is not an air barrier. It stops conduction. It does not stop air movement. And where there are gaps around light fixtures, around the attic hatch, at the top plate where interior walls meet the ceiling, warm interior air moves directly into the attic through convection. On a cold night, the attic might be 30, 40 degrees colder than the living space. The stack effect is pulling. The warm air inside is trying to rise, and if there are unsealed penetrations at the ceiling level, the warm air finds them. It doesn't matter how thick your insulation is. If air can move around it, the insulation is almost irrelevant. Ceiling bypass is the reason homes in cold climates sometimes show ice dams on the roof, even when the attic insulation looks adequate from below. The insulation stopped conduction, but it did not stop air, and the air carried the heat directly to the underside of the roof deck. The fix is air sealing, not more insulation. Air sealing first, then insulation. But number 3 is mid-weight, significant in heating season, less relevant in summer. Number 4 shows up in summer in the humid months. It's the rim joist. The rim joist is the band of framing that sits on top of your foundation wall, at the transition between the foundation and the first floor. It's exposed to the exterior. It's often uninsulated or poorly insulated. And in a humid summer, when outdoor dew points climb above 60 degrees Fahrenheit, it's one of the most active sites of moisture infiltration in the whole envelope. Here's the mechanism. The basement or crawl space is cooler than the above-grade living space in summer. Humid outdoor air enters through vents, through the rim joist gaps, through any foundation penetration. That air hits the cool surfaces near the rim and dew point. Moisture deposits. Over years, this cycles into wood degradation, mold establishment, and a floor that never quite feels clean in August. This isn't dramatic. It doesn't announce itself. But if your house sits on a full basement or crawl space, and you've ever noticed a musty smell after a humid week, the rim joist is almost certainly part of the story. Number 4 is a chronic, quiet drain. Not as acute as 2 or 5, but it compounds over time in a way the others don't. Now, number 5. This is the second item in the same weight class as the west wall. It's attic radiation at 2 in the afternoon. Your attic is not a passive space. On a summer day, a ventilated attic in the temperate U.S. reaches temperatures between 130 degrees Fahrenheit and 160 degrees Fahrenheit, 54 to 71 Celsius, by early afternoon. That's the air temperature in your attic. The roof deck itself, the underside of the sheathing, can reach 180 degrees Fahrenheit. That's 82 Celsius. And that surface is directly above your ceiling. There is insulation between them. The insulation slows heat flow, but it does not stop radiant transfer. The underside of the roof deck is radiating inward, downward, onto your insulation surface, which then conducts into the ceiling, which then radiates into the room below. This is why your second floor is always hotter than your first floor, even with the AC running. The first floor sits on a cool slab or basement. The second floor sits directly below a heat engine. No amount of AC corrects this efficiently. The load is too constant. The source is too close, and unlike the west wall, which peaks in late afternoon, the attic load peaks at 2 p.m. and sustains until well after sunset. Numbers 2 and 5 together. account for the majority of summer cooling failure in residential construction. If your house is uncomfortable in summer, and you're looking for where to start, you are looking at these two. The others matter. But these two decide the outcome. Number 6 arrives in September. It's subtle. Most people attribute it to something else: drafts, poor windows, thin walls. It's ground contact at the bedroom floor in early autumn. Here's what happens at the seasonal transition. The ground temperature at depth changes slowly, much more slowly than the air temperature. In September and October, outdoor nights cool quickly, but the soil below your slab or crawl space is still carrying summer heat. That sounds like it should help. But the problem is the reverse. In a cool autumn night, when you want the interior to feel comfortable, the floor slab is radiating warmth upward into the space. Not dramatically, but enough that the room feels oddly warm from below, slightly stuffy, never quite settling. This reverses by November. By then the ground has cooled and the slab becomes a heat sink. But in that 6-week shoulder window, the ground is working against the season you're trying to live in. The fix for this one is limited. It's mostly about expectation and timing, knowing why your house behaves differently in September than in January. Thermal mass at the floor level is a constant in both directions. Number 6 is low priority for action, high priority for understanding. Number 7 happens at night in winter. It's the window frame as a thermal bridge. You know about window glass losing heat. That's expected. You've accounted for it. Low E glass, double panes, you've done the work. But the frame is different. Modern window frames, aluminum, even thermally broken aluminum, conduct heat at a rate that is significantly higher than the surrounding insulated wall. In a cold climate, on a night below 20 degrees Fahrenheit, that's -6 Celsius. The interior face of the window frame drops below the dew point of interior air. Condensation forms on the frame, not on the glass, on the frame. And over a heating season, that condensation cycles into paint failure, wood rot at the rough opening, and eventual air leakage as the seal between the frame and the rough opening degrades. Number 7 is a slow process. It doesn't cost you much in any single winter. But over 10 winters, it turns a tight window into a leaky one. The fix is not replacing the window. It's reducing interior humidity in winter and improving the air seal around the frame perimeter, not just the glass. 7 items, 7 betrayals. Now, here is what you actually do with this list. Do not try to fix all 7 at once. 2 and 5 are responsible for most of the discomfort. In summer, in the hours between noon and 10 p.m., the west wall load and the attic radiation are the 2 places where physics is working hardest against you. Fix those 2, and you will feel the result in the same season. Number 1 and 3 are heating season problems. Air sealing at the top of the envelope, ceiling penetrations, and the rim joist addresses both simultaneously. 1 project. 2 symptoms resolved. 4 is a long game. Rim joist insulation and vapor management in the crawlspace or basement. Not urgent, but the kind of thing that costs you quietly for years if you ignore it. 6 you mostly live with. Understand it. Don't chase it with HVAC adjustments you'll undo in 3 weeks. 7 is a maintenance and humidity management question, not a replacement question. The list is not equal. It never is. 2 items carry 60% of the load. The rest is refinement. Your house has 7 moments of betrayal. 2 of them decide most of the outcome. Start there. You just couldn't see it.